Hello, this lesson is on factoring. So we want to start by understanding the word factor. What does it mean to factor? Well, the word factor in math means a number or expression that divides evenly or without a remainder into another number or expression. So that's what a factor is. So to factor means to write a polynomial expression as a product of two or more expressions. So division and multiplication go together. So when we say we want to factor, that means we want to write the expression as a product of two or more expressions. So let's do an example with numbers. So if I said to factor 24, that means to write this number as a product of other numbers. And usually we say prime factorization. So factor 24, we could start with, well, 24 is 2 times 12. And 2 is prime. So you can break down 12 and say, well, 12 is 2 times 6. And then 6 isn't prime. So you can break down 6 and say, well, 6 is 2 times 3. So 24 factored would be 2 times 2 times 2 times 3, or 2 cubed times 3. And each of these, those are factors. All right, so 24 has 2 as a factor and 3 as a factor. Now we'd have 2 cubed to 2 times 2 times 2 times 3. So that's what it means to factor. We have now factored 24. Okay, so I've come up with a factoring checklist, and it's kind of in order, but sometimes it's not going to be in this order, but it is in order in this way. When you're factoring, you always want to check to see if there's a greatest common factor, because that's going to reduce the size of the expressions that are left. So that's going to help it make it easier for you. And the second thing you want to look for is, how many terms are there? So there's a lot of rules. I'll read through it, but then this is really to help you later. So terms, remember we've talked about terms. If it's a binomial, that means if it has two terms, and if it doesn't have a GCF, it might be something called a difference of two squares, which is nice. If you have a squared minus b squared, a difference of two squares, it's going to factor into a plus b, a minus b. B, if it's a quadratic trinomial, 3 terms, and the degree is 2, so a degree 2 trinomial, then you can try to factor it into 2 binomials like this, and I call this guess and check. Or some people call it trial and error. And some teachers teach this the grouping method, or they use something called the AC method, but I think that this is the best method. And I break these factor and quadratic trinomial problems into 3 cases. It's easy when you compare to the 3 cases if the leading term is 1. It's kind of medium if the leading term is a prime number like 2, 3, 5, 7. And it's the hardest type, still can do it, if the leading term is not prime, like 4, 6, 8, 9, etc. And then if it has 4 terms, then we're going to try to factor it by the grouping method. Okay, so that's our factoring checklist. And then the third thing is sometimes it's going to be necessary to factor more than once within the problem. And so that's called factoring completely. And that's like this. So remember how we started factoring 24 and it was 2 times 12? That's factored. 2 is a factor, 12 is a factor. But it's not factored completely until you've broken it down into prime factors. So sometimes you have to do that with expressions. All right, so we'll break the examples down. What does it mean to factor out a greatest common factor? And this is always the first thing you want to look for. Sometimes I forget. You can do it at the end, but you do have to factor completely. So it's easiest to catch it first. So what you can do is you can look at the numbers first. And is there a factor in common between 5 and 30? Well, 5 goes into 5. So 5 times 1 is 5, and 5 goes into 30, 5 times 6. So that means you could pull out a 5 and write it down. Now, the variables, there's a trick to the variables. So if you have x squared and x, right, so that's x times x, and that's an x to the 1, right? So you're going to pull out what they have in common, and they only have one x in common. So you can pull out one x. So the trick is, with variables, you just pull out when you compare the x as x squared, x, the one you pull out the smallest amount. Okay, so same thing with the y's. They have a y in common. Well, that's one y, and that's y times y times y. So you can pull out one y. Okay, so that is your greatest common factor. All right, to find the other factor, remember a factor, to factor means write this expression as a product of two factors, and we know that the word factor means it's a number that divides evenly. So this number divides evenly into that expression. This expression divides evenly into that expression. So we can use division to figure out what's left over. So 5 divided by 5 is 1. X squared divided by x is x. And y divided by y is 1. So all you're left with when you divide out that factor is 1x. That's the first term. 30 divided by 5 is 6. You pull out an x. So there's x divided by x is 1. There's no more x's to put down. Y cubed divided by y is y squared. And so I kind of think of it as pulling out, especially with the variables. So if I pull out one x, there's an x left. If I pull out one y, there's not a y left in the term. So now this is factor because this is a product of two expressions. And we could check our work by multiplying it back out. So that's factoring out of GCF. Okay, this expression has 3 terms. So we're going to pull out the GCF. Look at the numbers first. You have an 8, a 2, and a 4. So it's the biggest number that goes into all 3. So it can't be 4 because 4 does not go into 2. But 2 goes into all 3. See, 8 is 4 times 2. 2 is 2 times 1. And 4 is 2 times 2. So they all have a 2 in common. And then do you remember the trick for exponents? That's x times x times x, that's x times x, and that's x. So I can pull out the most I could pull out is just 1x. And then to figure out what's left, 8 divided by 8 divided by 2 is 4. X cubed divided by x to the 1, or if you pull out 1x, you're left with 2 x's. Minus 2 divided by 2 is 1. X squared divided by x is just x. You pulled out an x, so there's one x left over. And then 4 divided by 2 is minus 2, and you pulled out the x. All right, now, we're not going to do that for this one, but notice that this is a quadratic trinomial. So it's 3 terms. It's quadratic because that's an x squared, a degree 2. And it's in descending order. So this might factor again. And you'd have to try that, but we haven't learned how to do that yet, so we're not going to do it yet. All right, that's factoring out a GCF. Okay, that's not going anywhere. You always have to check that. But now let's move to factoring out a difference of 2 squares. Okay, so first thing you want to do is check, is there a GCF? Well, 25 is 5 times 5. And 36 is 6 times 6. They don't have anything in common, but you see how they're perfect squares? Not only that, x squared is x times x, and y squared is y times y. So this is how a difference of 2 squares work. You have a perfect square here, and you have a perfect square here, and their subtraction. So difference of 2 squares is going to simply factor into a plus b, a minus b. So this would factor into 5x and 5x, because 5x times 5x is 25x squared. And then 6y and 6y, because 6y times 6y is 36. And the signs, they're going to be opposite signs in here. All right, so that's factored now because that's a product of two things. Now I'm going to multiply this out so you can see why this works. So if you multiply out, remember you can FOIL or double distribute. So 5x times 5x is 25x squared. And then 5x times negative 6y is negative 30xy. And then 6y times 5x is positive 30xy. And then 6y times negative 6y is negative 36y squared. See what happens with these middle terms? One's a negative 30xy and one's a positive 30xy. And that happens because of these opposite signs in here. So you've got the same numbers in here. That's going to give you an outer term and an inner term that are opposites. So that's why if you have a difference of 2 squares, you can factor it into a plus b, a minus b. So you want to memorize that. Okay, so it helps to know your perfect square so you can recognize it. 49 is 7 times 7, and x squared is x times x, and 16 is 4 times 4, and there's a minus, so that's a difference of 2 squares. So that's going to factor into two binomials, 7x plus 4, 7x minus 4. Okay, so that's a difference of 2 squares. So if you have two terms in subtraction and perfect squares, you can factor that. Okay, now we're into factoring quadratic or degree 2. You're looking for x squared, degree 2. And it's in descending order, so you have x squared and then an x term and then a constant. So when you see a quadratic trinomial, there's a trick to factoring it. If it factors, it's going to factor into two binomials. There's a product there, that's factoring. Okay, so the reason I call this the easy example is because if this is just x squared and there's just a 1 there, then I know that the first spot is just going to be an x and an x, because x times x gives me x squared. So I really don't have to think about that first term much when there's just a understood 1 there. So all I have to do is really check the last term. Okay, so what we're going to do is we're going to write a list of the things that give me 18. Now, some of us are good with our times tables, and some of us are not. So I do want to just quickly show you that you can do this on the calculator if you go to the table and hit number 2 and clear. And if we're trying to factor 18 and figure out everything that 18 goes into, what you can do is do 18 divided by this x right here, which is to the left of the 4, and then hit enter. And if you want to start at 1, that's a good idea, and count by 1. So, so start 1, step 1, and then auto. And then what happens if you hit calc down here is it'll kind of give you a list of all the factors of 18. And I see a 1 in 18, 2 times 9, 3 times 6, and then it starts to be decimals. We don't want any decimals. And we can tell we're done because 3 times 6 is 6 times 3. And so once it starts repeating, you're done. So we have 1 times 18, 2 times 9, and 3 times 6. So you can use that calculator. If this, use that for the numbers. Like if you've got like 90, then it's might be helpful. Okay. So we write down the factors of 18, and then the next thing we're going to do is look at that sign. The sign in front of the 18. If that's a minus, then these factors need to subtract to be this number right here, 7. And I notice I didn't say negative 7. I do that later. Because first I just want to know which numbers subtract to be 7, and that would be 2 and 9. So I know it's 2 here and 9 here. And then the last thing I do is I want them to subtract to be, or add up to be a negative 7, right? So I use my adding rules. If this is a minus, these signs are going to be different. We know that. We should know that. Okay, so if that's a negative, you've got to have a positive 2 times a negative 9, or a negative 2 times a positive 9. Well, that needs to be add up to be, these numbers need to add up to be a negative 7. So negative 9 plus positive 2 gives me a negative 7. So it's factored. All right, let's try another one. So here we have p squared minus 5p minus 14. That's a quadratic trinomial. If it factors, it's going to factor into two binomials. It's just p squared, so we know if it factors, it's going to be p times p. The factors of 14, 1 and 14, 2 and 7. And you look at the sign right here. We need to find the factors that subtract to be 5. That's 2 and 7. We need them to add to be a negative 5. So negative 7 plus 2 is a negative 5. All right, those are the easy ones. We'll come back and do more, but let's go ahead and get to the medium ones. All right, because this is where it gets harder. Okay, so notice the difference. There's a 3 in the front. This is still a quadratic trinomial, but now there's a number other than 1. And the reason that makes it harder is because you now have to account for that. So what we're going to do is we're going to draw a little alien. I like to think of it with antenna. So we've got to write the factors of 3. And this is what makes this medium, is that 3 is prime. All you got is 3 and 1. That's it. And 2 this time is pretty simple to write down 2 because it's just 2 times 1. All right. Now, if this factors, it's going to factor into two binomials. All right. Now, what I'm going to do is go ahead. I know that the only way we can get 3x squared is if you have 3x and x. So I'm going to put that pretty solid. Okay, now, because it's not even anymore, this is 3x and this is x as opposed to x and x, this is where the outer and inner terms come in from FOIL. So first times first, outer times outer, inner times inner. So drawing my little alien. It has a unibrow and a little smile. Okay, so we have to think about the outer and inner terms. And so I'm going to try, and I'll do it wrong first so you can see. So I'm going to try to just guess where this 2 and this 1 goes, because it's going to make a difference now since this is 3x and that's x. So if I put, so I won't do it wrong, 1 here and 2 here. Let's see if that works. Okay. You still look at this sign. This time it's add. So the outer terms and the inner terms, not just the 1 and 2, the outer terms and the inner terms need to add to be 5. So you have to kind of do this. 3x times 2 is 6x, and 1 times x is 1x. And 6x plus 1x is 7x, not 5x. So that means that's not going to work. But because, again, it's not even, I have to try to switch this up. Let's put 2 here and 1 here. And then you try your outer and inner terms. So 3x times 1, that's 3x. And 2 times x, that's 2x. And do these two outer terms add to be 5? Yes, they do. So we know we've got the right numbers. And then the last thing I do is I just want them to add up to be a negative 5. Okay, so negative 3x plus a negative 2x gives me a negative 5. So that means that needs to be a minus, and that needs to be a minus. So if this sign is a plus and the middle sign is a negative, the signs are going to be the same, but they're going to be negative. If this is a minus, the signs are going to be different. If this is a plus, signs are going to be the same. All right, so that's that one. I'll speed up a little bit on this one. Oh, here's a 60, so let's figure out the factors of 60. So we'll go again to table, and 2, and then 60 divided by x. All right, and it's starting at 4, so let's go back to 1 and calculate. We'll write all these factors down. So we have 1 and 60, and 2 and 30, and 3 and 20, and 4 and 15, and 5 and 12, and 6 and 10. And then it starts to be a decimal, but that doesn't mean we might have more. And then 10 and 6. So once it repeats, you're done. So that's a lot of factors. And then 7 is just 7 times 1. That's what makes this a medium difficulty. Because if this factors, it's going to factor into 2 binomials. And because that's your only choice, we know this is going to be 7g and 1g. Okay. But it makes it uneven, so you have to check your outer and inner terms. And we have to find outer and inner terms that together subtract to be 32. And there's a long list. So I have a tip for you, and that is always try the factors closest together first. So, and once you get good at this, it'll be quicker than what it's going to feel like right now. Okay, so with a pencil, I'm just going to put in 6 and 10. And that gives me 70 and 6. And they don't subtract to be 32. All right, so I'll switch it and try 10 and 6. And that's 42 and 10. And on the second try, I got it because 42 take away 10 is 32. So see, I have the right numbers. So 7g times 6 is 42g. 10 times g is 10g. Now I got the right numbers now. The last step is I have to figure out how to get them to subtract to be a negative 32. So the signs are going to be different because that's why when you subtract. So I want the 42 to be negative and the 10 to be positive so that they add up to be a negative 32. So I'm just going to follow these little brackets out. That would make that 6 a negative, and this 10 would be positive. And so now it's factored. 7g plus 10 times g minus 6. All right, let's keep trying. All right, here, the factors of 2 are 2 times 1. The factors of 15 are 1 times 15 and 3 times 5. If it factors, it's going to factor into 2 binomials. That's the only thing it could be, so that's 2x and x. Okay, now it's time to try outer and inner terms. They have to subtract to be 1. Okay, so I'm just going to try in order, closest together. So let's try 3 and 5. That would be 10x and 3x. They do not subtract to be 1. Let's try 5 and 3. That would be 6x and 5x. That works. They subtract to be 1. So I got the right numbers. So 6x needs to be positive, 5x needs to be negative. Remember, the signs are going to be different if that's a minus. So we're going to follow these arrows, and that would be plus, and that would be minus, and it's factored. Okay, let's keep going. Let's try another one. Check the factors of 3, 1 times 3, and the factors of 40, 1 and 40, 2 times 20, 4 times 10, 5 times 8. If you won't need to use your calculator, you would put in y equals 40 over x. You hit the table. Okay, so this is a quadratic trinomial. If it factors, it's going to factor into 2 binomials, 3x and x. Okay, this time it's a plus. So the outer and the inner terms are going to need to add up to be 23. Okay, so try the closest ones together first. And can you do it in your head? So what you're doing is outer and inner. 8 times 3 is 24. 5x. 24 plus 5 does not equal 23. If you can't do it in your head yet, just keep doing this the long way. So we'll try 5 and 8. That's 24x. That's 5x. Do they add to be 23? No. Let's switch it up and try 8 and 5. 3x times 5, that's 15x. 8x. Do they add to be 23? Yes, they do. So you want them to be a positive 23, so plus 15 plus 8x, so this one's a plus plus. 3x plus 8 times x plus 5, it is now factored. Expressions written as a product. Okay, let's now do the hard ones. What that means is Still going to do it the same way. But now, the reason that they take a little longer is because now this number in the front isn't prime. See, 10 can be 1 times 10 or 2 times 5. And 9 could be 1 times 9 or 3 times 3. So we have a lot of choices to cycle through. All right, so but still, if this factors, it's going to factor into 2 binomials. And our outer terms and our inner terms are going to need to be subtract to be 89. Now, after you get good, you start to notice that middle term, 89, subtract to be 89. That means that one of the numbers probably should be pretty big. So I usually say start close together, and I'm going to do that, but I feel like it's going to be 1 and 10 and 1 and 9. But just to show you the quick way you want to do this is you just want to write lightly 2x and 5x. Let's try 3 and 3. And sometimes you don't even have to write it down. You can just put your fingers here. 2x times, that's 6x, that's 15x. That doesn't subtract to give me 89. And I don't have to try 3 and 3 anymore because switching it wouldn't do any good. So 1 and 9, that's 18 and 5. They don't subtract to be 89. Let's try 9 and 1. That's 2x and 45x. They don't subtract to be 89. So see, once I've tried this 2 and 5 with both of these, I now know it's not 2 and 5, as I suspect. So if this factors, it better factor with 10x and 1x, or else it just won't factor at all. So we'll try 10x and 1x. We'll start over. 3 and 3. That's 30x and 3x. They don't subtract to be 89. All right, let's try, do it wrong here. 9 and 1. That's 10x and that's 9x. They don't subtract to be 89. Let's try 1 and 9. That's 90x and 1x. And there we go. They subtract to be 89. So I want positive 89. So plus 90 and minus 1 work. So follow the arrow. 10x times positive 9 gives me 90x, and x times negative 1 gives me negative 1x. All right, so it's perfectly natural for us to start to peek in at that middle term, and when it's a hard one, you might want to just look and see if you can figure out kind of what it is before you start. All right. Number 12, you got 9 here, so the factors of 9 are 1 and 9 and 3 and 3. And the factors of 70 are 1 and 70 and 2 and 35. And I don't know if there's any more, so see, even me, after I have to think for a minute, I might as well just put in 70 divided by x and let the calculator help me out. And those are factors 1 and 70, 2 and 35. Oh, see, 5 and 14. Let's see if there's any more. 7 and 10, which I would have gotten that one. And then it's going to start repeating. So that's it. So I know I've got all the factors, and I want to factor this quadratic trinomial. If it factors, it's going to factor into 2 binomials. Okay? And the outer and inner terms are going to need to add up to be 73. And I just don't see what it could be. I will try 3g and 3g. And we're going to have to start here. 7 and 10. That gives me 30 and 21. Don't need to worry about switching because they're the same. 5 and 14. Let's see what that is. 14 times 3 is, oops, I'm doing the wrong thing. 14 times 3 is 42. And 5 times 3 is 15. And 42 plus 15 is 57. So this is a hard one. This is the hardest one I've done in a while. So it's not 5 and 14. Okay, let's try 2 and 35. 35 times 3 is bigger than 73. It's not going to be those two. So it's not 3 times 3. I had a feeling, but see, when you're not used to this, you may not have any kind of feeling. So let's try 9 and 1. So it's not that. Try 9 and 1. 7 and 10. Let's see. 7 and 10. That's 90 and 7. They don't add to be 73. So in my head, I'm kind of just doing the outer and inner in my head. 10 and 7. What is 9 times 7? 9 times 7 is 63. And 10 times 1 is 10. They add up to be 73. So we want it to be a positive 73. So that's 9g plus 10g plus 7. You can see why I call this the hard kind, because it's kind of hard to see what they are, but there's a method to it and you can do it. All right, now let's look at 13. Do you remember the checklist? Once you get going on these quadratic trinomials, sometimes it's hard to remember that. You always want to check to see if there's a greatest common factor first. And if you can recognize that, it can help you factor, because your numbers would be smaller. So look at this one. It has a n to the 4th, n to the 3, n squared, and then 28 and 16 and 80. So we need to pull out a GCF. Kind of hard to see what the GCFs of the numbers are going to be. I know 80 is 8 times 10. And I know 16 is 8 times 2. But the bad news is 8 doesn't go into 28. So it's not going to be 8. You can't pull out an 8. So 4 goes into 8, and 4 goes into 8, and 4 goes into 28. So the GCF is 4. Okay? It's not those. All right, and then the variables, remember our trick? Yeah, n to the 4th, n to the 3, n to the 2. We can pull out the highest one of those. The smallest of those. So n squared, we know goes into n cubed and n to the 4th. Okay, so now to figure out what's left, you divide. All right, so if you're good with your times tables, you can just do 28 divided by 4 is 7, or you can use your calculator. If you pull out n squared out of n to the 4th, that's n squared. Then 16 divided by 4 is 4. You pull out n squared out of n cubed, that's n. And then 80 divided by 4 is minus 20. And then if you pull out an n squared, there's nothing left. Okay, so now listen to this. Remember how I said you're going to have to factor completely. So we pulled out the GCF, but notice that there is a quadratic trinomial right here. So we're not done yet. So this 4n squared is a factor. It's going to come down. But this is a quadratic trinomial, and it's going to possibly factor into two binomials. So again, you have to do your little antenna. Factors of 7 are 7 and 1. That's good news. This is a medium one. We know it's 7 and n and n. And the factors of 20, 1 and 20, 2 and 10, 4 and 5. They're going to need to subtract to be 4, the outer and inner terms, not just those numbers. Okay, so can we do it in our head? Let's see. I'm trying them all. I don't think it's going to work, but let's try it. 4 and 5. They need to subtract to be 4. That's 35 and 4. That's 31. 5 and 4. That's 28 and 5. They don't subtract to be 4. 2 and 10. Look at that. That's 70n minus 2n. That's not going to work. 10 and 2. That's, oh, I missed it. Look. 10 and 2. Let me write that better. Look at that. 7n times 2 is 14n. 10 times n is 10n, and they sure do subtract to be 4. So I found it. So it needs to be a positive 4, so plus 14 minus 10. Follow that arrow. 14n comes from 7n and 2. 10n comes from negative 10 and n gives you negative 10n. So now, see, this is now factored completely into 3 factors, GCF, and then factored into 2 binomials. So that happens sometimes. Okay, so here we have a 4, a 43, and a 30. So 4 does not go into 43, but we have an x cubed and an x squared and an x. So you pull out the smallest one, the x is x to the 1 is all you can pull out. That's going to leave you with 4x squared plus 43x plus 30. And you have to check. That's a quadratic trinomial, so that might factor into two binomials, outer and inner terms. So the factor of 4, this is a hard one because 4 is 1 times 4 or 2 times 2. 30 is 1 times 30, 2 times 15, 3 times 10, 5 times 6. All right, so the outer and inner terms are going to need to add up to be 43. So I'll try 2x and 2x, and we have to try these. So that's 5 and 6, that's 12 and 10, that won't work. Let's try 3 and 10, that's 20 and 6, that won't work. Let's try 2 and 15, that's 30 and 4, that won't work. Let's try 1 and 30, that's 60 and 2, that will not work. So it's not 2x and x, not 2x and 2x. So if this factors anymore, it'll be 4x and 1x. So now we have to try it again. Let's try 5 and 6, that's 24 and 5. It's not going to work, but we have to switch it because these are different this time. So 6 and 5, and that's 20 and 6. That won't work. And let's try 3 and 10, and that's 40x and 3x, and that adds up to be 43 plus plus. Now, at this point, you're probably getting a little tired. We've got some good news for you. These are really hard. These last 4 that we've done. You probably won't see one that hard on the test, but the more you practice, the better this gets, the quicker this gets. All right, so you have to commit to practicing. Okay, so those are the examples I have for factoring out a quadratic trinomial. It takes practice, so if you look at the next page, I have a lot of practice problems. So you might want to stop here and just practice, and then go and check the key, and then come back for the end of the lesson, which is factoring by grouping. Okay, so factoring by grouping. So there's 4 terms, so it's not a quadratic trinomial. So what you want to do is you want to look for another technique. Factoring out a GCF, we want to check that out. So look at all 4 numbers, 12, 4, 15, and 5. There's not a number that goes into all 4 of those. Look at the variables, xm, xy, pm, py. You can't pull out a variable among all 4 of those. So the next thing you do is you want to try to see if factoring by grouping works. And so what that means is you want to just group the first 2 and the last 2. Don't use parentheses, you just kind of mentally want to do this. So if you look at the first 2, they have a 4 in common, 12 and 4. And they also have an x in common. So that's one of the factors of these first 2. So to get the other expression, you divide 12xm divided by 4x is 3m. Minus 4 divided by 4 minus 1, and then there's a y left. Okay, so now we've only factored out the first 2, so that plus is still in play, so you have to put that down. And then you try to factor out a GCF among the second 2, and that would be 5, and then they have a p in common. So 15 divided by 5 is 3. Pulled the p out, you got an m left. Minus 5 divided by 5 is minus 1. You pulled a p, you got a y left. Now, notice that this isn't factored yet. There's still a plus in between these 2. So we've got another step with grouping. But you do want to notice that among these 2, this 3m minus 1y is here and here. So you can actually factor out that. And then what's left would be times, there's a 4x left in that expression, and then there's a 5p in that expression. So when you're done, you are factored. You factored into 2 binomials. So that's factoring by grouping. All right, so let's look at this one. X cubed, x squared, x, and then 8. So since that doesn't have an x, you can't pull an x out of all 4. but you can mentally group the first two and the last two. So if you pull out the GCF among the first two, that would be 5x squared. And that's going to leave you with x plus 2. All right, now this minus here is tricky. So this is a minus 4x, and that's a minus 8. So we're going to pull out a minus 4. Now you have to be careful with the minus. So a negative 4x divided by negative 4 is just positive x. And a negative 8 divided by negative 4 is a positive 2. So then you want to check your work. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. And now you look at these two together. They have an x plus 2 in common. So you pull that out. And what's left is this x plus 2 is multiplied to the 5x squared. And then that x plus 2 is multiplied to minus 4. So there's your two binomials. That's factoring by grouping, and if there's a minus, it gets a little tricky. You have to pay attention to your signs. All right, let's do these. Look for GCF among all 4 to make life easier. 9 doesn't go into 25, 3 doesn't go into 25, so there's no GCF among all 4, so let's look at 2 at a time. 25 goes into 125, and you can pull out an x squared. So that's going to leave me with x plus 125 divided by 25 is 5. All right, now remember what we're doing with the minus 9x minus 45. In here we got positive, so that means we're going to pull out the minus 9, and that's going to leave us with positive x. Look at this, negative 45 divided by negative 9 is positive 5. So if you have the same thing here and here, you know you did it right. So the second step in grouping is you pull out what those two things have in common. They have an x plus 5 in common. And that leaves you with 25x squared minus 9. Now, you have to be observant because we have to factor completely. This is done. This is a linear binomial. But this one, do you notice what this is? This is a difference of two squares. So this can be factored into two factors. So the x plus 5 comes down, x plus 5 times, and then this factors into 5x plus 3 times 5x minus 3. So now that's completely factored. All right, let's look at the last one. 4 terms, nothing in common. So we're going to group these two and these two. You can pull out a 9x squared. And what's left is x plus 2. So you have x plus 2, so that gives me a hint. We're going to pull out a minus what? They don't have anything in common. Yeah, they do. They have a minus 1 in common. And the reason that is really good is because negative 1x divided by negative 1 is positive x, and negative 2 divided by negative 1 is positive 2. So by pulling out the negative, that gives me that x plus 2 that I need. So then that's going to be x plus 2 times, they have an x plus 2 in common, 9x squared minus 1. Okay, are we done? There it is again, a difference of two squares. So that's going to bring this x plus 2 just comes on down, but this factors into difference of two squares, 3x plus 1, 3x minus 1. So it's kind of helpful to know your perfect squares. Okay, so that's the end of the factoring video. As I said, you have a lot to practice, so go and practice these and check the key.